Hey guys, so quick video going over normalization from the workshop and the examples that I think would help a lot with understanding this. So, um, starting off, you guys went over what a relational database is, and I hope that you guys, I'm sure that you guys have some kind of understanding of what they are. Um, but one of the things that doesn't get really mentioned that often is why we actually use relational databases. We know that there's different types of relational databases, but there's also different types of databases and storing our databases. We have NoSQL databases that don't use SQL. We also have things like Excel and spreadsheets. But one of the biggest reasons why we use relational databases is because we can achieve this thing called normalization with them. And it's so important. It's actually literally one of the first things that we go over in workshop one. Go over what relational databases are, a little bit about ER diagrams and how to read them so we can get right into this really important thing. So, when I was learning about normalization in college, the professor just gave us the definition and kind of moved on. But if you start off with just a definition, it doesn't really make that much sense. So for me, and when I'm teaching this, I like to kind of go over the intuition first to see what exactly it is to get an idea about it, and then we can dive into the actual definition, and it'll make a lot more sense. So you guys are already familiar with this example. We want to create a database for a veterinarian clinic. So what is the first piece of data that we want to track? Probably the pets. So we go create a pets table right here, and it's also going to have some attributes like age, species, name, and owner. And just this looks fine as it is right now, but problems start to pop up when we actually go and add excuse me, more information for the owner, and like it's the owner's phone number and the owner's name. So obviously you guys know that this is a bad idea. um, and we know how to fix this. How do we fix this? We take the owner attribute, we give it its own entity, and we create a relationship between these. But what's not so obvious is why is this, or why is this bad, and why is this good? Just looking at this, you can tell right here, you have two different entities inside the pet table right here. Just from an organizational standpoint, this doesn't really make that much sense that pet would be responsible for storing information about its owner. And this looks like a lot more organized. But when we have our tables like this, and I'm just going to tell you that these are normalized right now, we'll get to it, but um, we end up having a lot less data redundancy, and we save a lot of storage and computation. So let's take a look at this example right here. This is my screen recorder. I don't have one. In Google Sheets, and we can actually look at these tables right here. So right here, this is our bad example. And just by looking at the data, we can kind of see that this is not okay. So pet is going to be responsible for storing information about the owner. And I think it says it on the slide, but you know, it doesn't. But what would happen if a pet has multiple owners? This is very common, at least in America, or Los Angeles, where I live. A lot of people have multiple pets. They have two cats, a few dogs, maybe a bird. But we can see here that this pet owner, this is me, Eric. Hi. We're pretending that I have four pets. And if a pet is responsible for storing information about its owner, each pet, then if I have four pets, each pet is going to have to store my information and be responsible for that information as well. So this is going to get stored four different times. And if I want to get another pet, if I want to adopt a bird, his name can be Oliver. I'm gonna have to store my information again, and this is just, you know, space wise, this is not this is not space efficient at all. I'm storing, n times the amount of information that I have to, where n is just how many pets I have. So if I have, like in our original example right here, if I have 4 pets, you're going to have to store my information 4 different times. So storage wise, as this database grows to any kind of meaningful size, your storage is just going to absolutely blow up in proportion. You're going to be wasting a ton of money on database storage. And I know storage is cheap, but it's going to just grow. It's going to grow at an exponential rate. Um, the second thing is that this is computationally not efficient at all, for a few reasons. If I go and I say I move, and I move from 1 Culver Street to, let's say, 1 Main Street, and I want to make that change in the database is going to have to look through every single pet and see if Eric is its owner, and then go and change that owner's address. So it's going to look at here. I mean, it's easy just because I have literally 4 examples. It's a small database, but it's going to have to look at the second one and go to Eric and then go and change it to 1 Main Street. It's going to have to go again, change it to 1 Main Street, and look at the fourth one and change it again to 1 Main Street. And that is just completely not computationally efficient. Again, if this scales up to any meaningful size, you're going to be paying a lot more for processing power in your database. On a best case scenario, worst case or really common case scenario, you have any meaningful amount of users, meaningful amount of data, your application is just not going to work. It's going to crash. It's going to get completely overwhelmed. You're not going to be able to scale it up. And that's going to be hard to explain to the person or the company that is paying you. So again, so how do we fix this? We already know how to fix this. We go and we normalize our tables. We'll get to the definition. So we take this pets table, we take this owner attribute, we pull out the owner attribute to its own table, and we create a relationship by putting a foreign key on this auxiliary or additional owner ID column, and we point it to this owner column. So we have this relationship now between these. So now if I want to go change my phone number, I can just go to where my ID is and just change it. I don't have to go look up pets and map it to the owner, and then for every single pet go and change that. I just do it one operation instead of really an exponential amount of information as my app scales up. If I want to go change to the house across from me, 7 Main Street, I can do that really easily too. And so this is computationally a lot more efficient than the last one. Your app is actually going to work and run and scale in this one. But not only that, this is space efficient. It doesn't matter if I have 1 pet, 10 pets, or 100 pets. I'm only going to have to store the owner's information one time and not have to worry about that. So space efficient, I'm saving a lot of money and saving a lot of space on that as well. So now that we kind of know why we want to get normalization, now that we kind of have an intuition behind this, we can kind of talk about what normalization is, what the actual definition is. So to do that, we're going to go to this good slide. I'm going to bring up a new vocab word called atomic. So I always ask students, like, does anyone know what atomic means? If you do know what it means, that's great, but we're going to go over the definition. So atomic is based off of the English word atom, like, the atom, like, molecules, stuff like that. An atom is the smallest piece of matter in the universe. And I'm not a science person, I'm not a science communicator, but I do know that an atom, it's so small that you can't split it up. So if I say that something is atomic, that means it can't be split up. It can't be divisible. So when I'm looking at a database, I want to make sure that every single one of my tables are atomic. That is, there should only be one entity inside of a table. There shouldn't be 2 or multiple entities. Every table should only have one entity such that I can't split it up into multiple ones. So again, our example right here, is this pets table right here atomic? No, because I actually have two entities. I have a pet object, a pet entity, and I have an owner entity right here. And if I want to go split it up, then yeah, I'm going to have atomic tables. Excuse me, I have a pets table right here. I can't split this up anymore. And an owner's table right here. I can't split that up anymore. So because each of my tables are atomic, I can say with confidence that this database is normalized. So really the definition of normalization, if anyone ever asks you in an interview, you want to really impress them, the definition of normalization is that there's only one entity in every single table, and that each table in your database by this way is atomic. And that's what normalization is.